So in the previous lesson, I tried to give you some more theoretical introduction to name binding and mutability. In this lesson now, I'll try to give you a more practical introduction. What can we do to figure out what's going on? So I strongly suggest that in parallel to viewing the video, you also use the Python tutor online to understand the examples yourself. Really, this is incremental. I'll go from simple to more complicated examples. So really follow them online, trace them one by one to see what's going on. As we saw, an object in Python can have several names. So let's see the first example of that. I assign 2 to A, and then I assign the object that A is assigned to also to B and C. So A, B, and C are all bound to the same object. How can we see this? Well, id, the function id in Python, will return the position in memory of the object A. And I can do the same thing for B and C, and you will see that they're all three the same. So the variable names A, B, and C are all pointing to the same object. So if I do a full test like this, I get true. So there is a shorthand for this, for testing equality of the identifiers of both A and B. And this is is. So the function is, or the operator rather, is test whether the identifier of both sides are equal. So in this case it would return true, and this is exactly the same as the previous one. Okay, so this was a simple example with integers, with ints. So let's now look at an example where we're using lists. So first list will be assigned numbers from 0 to 4. Second list is bound to the same object. So when I print second list, I get 0 to 4. And this is the identifier of second list, which is also the identifier of first list. Indeed, if I do an is of the two, I get true. So what are examples where I can have different identifiers? Well, if I assign D to 7, then I had A, B, and C that were the same, and then suddenly I have a new object called D, whose identifier is completely different. So if I test A is B, I get true, but if I guess A is D, I get false. I can also take A and assign another value to it, let's say 5, and test if A is B. So A was B, but now A is not B anymore. The identifier of A has changed from before. It's not the same as the identifier of B anymore. Okay, so this is an example, and here is another one. If I take B and add 1, I'll create a new object. So B plus 1 is a new object. That's not bound to a variable name, but the point is it's a new object on memory that has a different identifier than B itself. And I can even do more sneaky stuff, like try to modify C with a value by doing a plus equal. So an augmented assignment, it's called. So I have C, and I look at its identifier, and I add C to itself, and I see that the identifier has actually changed. Okay, so this is for lists and ints, and it's the same for many other objects. One way lists and ints differ is that ints are immutable while lists are mutable. So let's see what the consequences are when we have two objects bound to the same object, two variable names bound to the same object. So this was the case with first list and second list, right? If you remember, this is returns true because they're both bound to the same thing. So let's see. I ask for the identifier of first list, and I modify the very first entry of first list to 17. So now if I print first list, I've changed it. It's not 0, 1, 2, 3, 4 anymore. It's 17, 1, 2, 3, 4. I've changed the content, but I haven't changed the identifier. Okay, so this is a crucial example to run in Python Tutor yourself to see what has happened. Now, I will compare the identifiers of first list and second list. So think hard about what should come out when I compare first list and second list. And the answer is true. Both of those variable names still point to the same object, but that object has now changed. The object is not 0, 1, 2, 3, 4 anymore. It's 17, 1, 2, 3, 4. So second list that we have never really seemed to touch, right? We have never said second list 0 equals 17. We only said first list 0 equals 17. Second list has changed. Both variable names were pointing to the same object, and in the back of second list, I've changed that object. So second list has changed, or the object that second list is pointing to has changed, even though I've never used the variable name second list. Okay? So another way of changing a list is not direct assignment like here, but it's appending values. So this, for instance, I would take L to be this list, 5711, and this has some identifier which ends in 560, and then I append to L 13 and then 14, and I print L and I get this. Nothing surprising so far, but then if I ask the identifier, this hasn't changed. Okay, so maybe this is surprising because this is different behavior than strings would have or integers would have, because integers and strings are immutable objects while lists are mutable. Okay, so be really careful with all those lists and having two variable names pointing to the same object. That can be very confusing. So on the left here, I've written a few lines that are essentially 5 lines repeated over and over again, but changing slightly the types from one to the other. So here it's ints, here it's strings, here it's lists, lists again, but I'm doing slightly different assignments each time. So this is a little test for you. Try to compare, try to think ahead of time what would be printed out of each of those and see if that's really correct. And if you don't understand something, run it through the Python tutor. Okay, so this was all already pretty complicated, but it gets even more complicated if there is nested data. So here I will assign to, or I will bind the variable name data to that string, Albert and a koala. And then I'll define a new list, nested, that will consist of twice the data. And I'll modify data by replacing koala by kangaroo. And then I will print data. I think that's pretty clear what this should print. And then I'll print nested. Now that's less clear what should happen, but if you think about it, you can figure it out. So let's see that. I have data and I've assigned Albert and a koala. Nested is the double list. And then I modify the second entry of data, or the second in Python indexing. So I get Albert and a kangaroo, and then I print nested. And I see that instead of having Albert and a koala, Albert and a koala, I now get Albert and a kangaroo, Albert and a kangaroo. So I've modified one entry in the object data that happens to appear twice in the object nested. Okay, so that's quite important. And then I'll take nested one, so this list, and append to it 5. But this list happens to be the exact same as that one. So I will have now the nested has changed. It has gained an extra element in both sublists. Okay, so now data is this, and let's see what happens if I take data 2 and I assign by hand exactly the same value. Now, is data the same as data 2? You should ask yourself that, and let's see the result. That's false. Okay, so data and data 2 are pointing to two different objects that happen to have the same value. Okay, so now if we had, we saw this behavior with Albert and a kangaroo changed, Albert and a koala changed to Albert and a kangaroo, and maybe we didn't like this behavior. So what should we do instead, or what are the alternatives? Well, one alternative is this one. So I reassigned Albert and a koala to data, and then I take nested to be again two sublists, But each time I use this construction, so this is slice assignment, slicing, but slicing with no bounds mentioned. So it's really taking a copy of data and taking a different copy of data and assigning both to the entries of nested. So if I print nested, I get the same as before, but the structure in memory is not the same. So if I now assign data 2, kangaroo to data 2, I've modified data, but this is holding copies of data, not data itself. So nested hasn't changed now. Okay? The alternative is to, or another way of changing things is to access the 0th entry, so this first list, and replace koala by kiwi. Now, before we saw that this was modifying both sublists because those sublists were actually the same object. Here, the two sublists are different objects, so only the first one gets modified. Okay, so the short summary of what we just saw is that lists in particular, or in general, mutable objects can be quite dangerous if you don't understand what you're doing. So I really, really, really recommend heavily that you look at the Python tutor and you try all those examples and get a better understanding by yourself of what name binding is and what the consequences are for mutable objects.